Hello, today I am going to size a sewage pump. Sewage is very nasty stuff and we don't want to get it wrong. We want to keep it moving. So I am going to first draw it out because I don't want to forget anything, right? This is going to be my sewage pump basin. Which pump I'm going to put in here, I don't know. I gotta size it. Now it's draining from my single family house. Okay. And it is a beautiful house with a front door. But that's besides the point. It's outside, so I should do it this way. So it is going to have a solid cover with no plumbing coming out the top. And it's going to have a discharge pipe that's going to go 500 feet horizontal and over a 10-foot hill. Okay. 10-foot hill. Total length of pipe from here to here is going to be 500 feet. Okay. So that's drawn out. I'll have an elbow right here. That elbow, I'm going to put a check valve right here. And what else? I really don't need anything else in there. That's pretty much it. So, to size my pump, I've got to start with the flow, right? Here, let me do this in red. We need 2 bits of information to size a sewage pump. We need flow, and we need total dynamic head, which sounds complicated, but it's not. Okay. So I'm going to show you how I find flow first, because we need to find the flow before we can find the total dynamic head. And to find the flow, I am going to use a information that is included in starting on page 100 of this little giant, come on, erase, of this little giant catalog. Can I erase? Here you go, erase. Oh, I can't erase. All right, I guess I'm stuck with my catalog looking all crazy. All right, so figure 1 over here to the left, figure 1. No. Erase. There we go. Figure 1, just figure 1 right here. It's going to help us add up what we call the unit value or fixture unit value. And we're going to use that on this graph on figure 2. So to start with, I'm going to add up every fixture in my house. Okay. And I've already got them highlighted, but I'll go ahead and go down the list for you. I have a bathroom group. Actually, I have 2 of those. So let me draw a 2 here, if I can do that. Unthickness that line there. And we'll say 2 of those. Well, which adds up to 12, so might as well write that in there. Dishwasher, got 1, which multiplied times 2 is 2. Kitchen sink, just 1 of those, so it's 2. And I have a washing machine, and it's a number 2 also. So now we're going to add it all up. We've got 12, 13, 14, 15, 16, 17, 18 total, 18. All right, it's a single family house. It's kind of normal size. So 18 it is. And so it's just below 20 right here, because the bottom line is fixture units. And that's what we were adding up, was fixture units. So we go over on the bottom line. We're just under 20, right? And so we follow 20 up to that line right there. And then we follow that line over to somewhere around 15. All right, so is 15 gallons a minute my flow rate? Well, it would be if it was clean water. But I'm going to show you why it's going to be more than that. So I'm going to scroll down. This tells you about total head, static head plus friction head, but we're going to get to that anyways. Highlight there, you know what to read later. Okay, so here is the line that's important. It says over here in highlighted, generally accepted to be 2 feet per second to carry solids efficiently through plumbing. All right, so we have some guidance here. We have a list of pipe sizes, 1.25 inch, 1.5 inch, 2 inch. I would either use a 2 inch or 3 inch for sewage normally. And certainly it'd have to be 2 inch because a sewage pump's going to pump a 2 inch solid. So I'm going to use, especially since it's going 500 feet, I'm going to use a 2 inch pipe. And it's going to have to be 21 gallons a minute for my scouring velocity. So I'm going to use this flow rate at 21 gallons a minute so I'm matching scouring velocity, and I'm not going to use the 15 gallon a minute flow rate the chart gave me. Had it been higher than 21 gallons a minute, certainly I'd have had to go with it, but I didn't. So now I'm going to go with 21 gallons a minute. Now I can take my 21 gallons a minute to figure 4, and I'm going to find 21. There's 20. And there's 25 gallons a minute. So I'm going to have to use 25 gallons a minute because I don't have a 21 and I need to round up. Always want to round up. So, and this is the flow rate. In this chart, I'm looking at the required flow rate because I'm going to get friction loss of my 500 feet of pipe. So I've got, and this tells us right here, the friction loss is shown in the chart is for every 100 feet. So I'm going to find 2 inch pipe right here because that's the size I'm using. Got my 25 gallons a minute. It merges right here. 1.29 feet of head for every 100 feet, right? So let's just, since I've already messed up my catalog, let's multiply it here. 500 feet times 1.29. What is that? I don't know. I'm just going to get a calculator and find out. 5 times 1.29. 6.45. 6.45. Uh-oh. Did I leave something out? I think I did. Remember I said I had an elbow? All right, where's my elbow? Figure 5. Figure 5. That is my 90-degree elbow that I left out. So I got 2 inch pipe, normal pipe size here. So I'm going to be in this row. I have a 90-degree elbow, and I also said I had a check valve, didn't I? Right there. So I have to add a little bit more to my pipe here, right? So I've got 17.2 plus 5.2. Let's go ahead and round that up to 25 because I already had to pull a calculator out once, right? So we're gonna give that a little bit higher value and make it 25. 525, right? I added this to this, and I got 525, which is this, and I'm going to multiply that times this because it's still the same friction loss per 100 feet of pipe. So 1.29 times 5.25. 6.77. I'm going to round up to 7. 7's a lot easier to remember. Let's go back over to my pipe here. My 500-foot run plus my check valve plus my, what was it, the elbow. All that together is 7 feet. Okay. All that together is 7 feet of friction loss. Friction, here, FL stands for friction loss. From now on, that's what FL stands for, friction loss. And I've got 10 feet of lift. So write my arrow up, and I've got to add this 10 to my 7, right? So I'm going to add, I'm going to write that out. 17. 10 plus 7 is 17. So I need, oh, I didn't write this up here. Flow rate, what was my flow rate? Scouring velocity of a 2-inch pipe, right? 21 gallons a minute. Why is that feet? It should be GPM. Scratch that. 21 gallons a minute at 17 feet. That's my total dynamic head. 17. Total dynamic head is vertical lift, which is 10 feet, plus friction loss, represented by the FL there, which is 7, which gave us 17 feet, right? So I need a pump that pumps 21 gallons a minute at 17 feet ahead. Simple. So let's go find us that pump. Now that I've messed up my pages here. Now there is a little chart at the bottom of this. And we could use this to quickly find 17 feet ahead, 21 gallons a minute. It looks like my 9SC pump is right on the borderline there. And my 14S and my 10S, let me write that. 21 gallons a minute at 17 feet. We're probably right here. That looks about right. So it is within the curve of the 14S and the 10. 14S, there's the 14S. See, look at all these other pumps. Weren't even included on the chart. All right, so there's the 10SC. What did I say? 17 feet at 21 gallons a minute. Certainly within the chart. So I could use the 10SC sewage pump. Or I could go down WSV 52, which wasn't on my list. 17 feet, 21 gallons a minute. It's about right there. It's within this curve, most importantly. I could use that pump. 14S. I've got 17 feet, 21 gallons a minute. You know, looking at this curve, it's just barely within the curve. And since it's a scouring velocity, since I'm pumping solids, I'm probably going to want to be a little bit, probably want to get be a little bit above it if I can be. So what are my WS pumps here? So 17 feet. This one's tough. Set about 21 gallons a minute right here. There it is. 17 feet, 21 gallons a minute. Probably about right here. So WS52. You know, I think I would probably use these WS52H and WS51 just because they're a little bit more above the curve. And oh, there I go. I picked out my pump. One of these two. Right here. And that's it. That's how you pick out a sewage pump.